So that is the area. Okay, next. Now I am continue Fourier series. Just 1 or 2 bits. After that I am going to give Dirichlet's conditions, that is sufficient conditions for Fourier series. (2010) f of x shown in the figure f of x, x-axis 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi, 1, and this is 1.5, minus 1, minus 1.5. Now the graph is considered between minus pi to pi, okay. So the period from minus pi to pi, pi to 3 pi, same shape and this interval. So consider the graph between minus pi to pi because the periodic function with period 2 pi, this one. So shown in the figure is represented by fx is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. Or you can write keeping for both terms one summation plus bn sin nx, then the value of a naught is, this is the question asked. So if you consider between minus pi to pi or 0 to 2 pi, same shape repeats. Okay? Solution. We have fx. So it is a straight line joining between 0, 1 and this is pi comma 1.5. And similarly this is a straight line joining between minus 0 comma minus 1 and 2 pi comma minus 1.5. Okay, so if you find that one, you will be getting 1 plus x over 2 pi if 0 less than x less than pi, and fx is equal to minus 1 over 2 minus x by 2 pi if pi less than x less than 2 pi. So this is the graph we can consider. From the graph, I calculated fx like this. So this value is obtained by straight line joining 0, 1 and pi comma 1.5. This is a graph between 0 to pi. Your fx graph is like this, which is a straight line joining this point and this point. What is the coordinates of this point? Vertical distance, that is horizontal distance pi, and vertical distance 1.5. So this point corresponds to pi comma 1.5. This point corresponds to 0 comma 1. Similarly, this is a straight line joining between the points pi x value y value minus 1, and this is 2 pi x value y value minus 1.5. So what is a naught? Original procedure 0 to 2 pi or minus pi to pi, having same answer a naught, a n, b n. That means refer your c comma c plus 2l, where c is equal to 0, l is equal to pi. Okay, so 1 over pi 0 to 2 pi f of x dx. So this is 1 over pi 0 to pi, what is fx value? 1 plus x by 2 pi dx plus 1 over pi, other interval, pi to 2 pi minus 1 by 2 minus x by 2 pi dx. Okay, so 1 over pi, 1 integration is x, x integration x square by 2, this simplifies to 4 pi, limits 0 to pi, plus 1 over pi times minus constant, that is constant integration, constant into variable, minus x integration x square by 2, simplifies to x square by 4 pi, limits pi to 2 pi. So this simplifies to 1 over pi, pi plus pi by 4, lower limit simplifies to 0, plus 1 over pi times, first substitute 2 pi upper limit, minus pi and 2 pi square, 4 pi square, this minus pi, lower limit is first put minus and then pi, minus pi by 2 minus pi by 4. So finally it simplifies to 0. See, minus pi minus 2 pi, and this is minus pi by 2 plus pi by 2. If you take 1 over pi common, pi minus pi cancelled, and this plus pi by 2 plus pi by 4 plus pi by 4, that simplifies to pi, pi with minus pi becomes 0, a naught value 0. Or if you consider the graph between minus pi to 0, 0 to pi, you will be getting same a naught value 0. Taking 1 over pi first common, pi first minus pi cancelled, and this is minus pi is there, plus pi by 4, this is minus plus pi by 4, 2 times of pi by 4, pi by 2, minus of minus pi by 2 plus pi by 2, this pi by 2, that pi by 2 simplifies to pi, and that pi, this minus pi, finally all terms cancelled. Here I am giving the hint ST, straight line joining the 2 points. First point is 0, 1 and pi, 1.5 is given by fx is equal to 1 plus x by 2 pi. That is the value, first value. Similarly, straight line joining where fx is nothing but y value, x is nothing but x only, joining other two coordinates pi, -1 and 2 pi, -1.5 is fx is equal to -1/2 minus x by 2 pi. You can check that the two straight lines correct or not, the equations. Y is nothing but fx. The next one is I am giving you one problem you do later. In the Fourier series of the function fx is equal to 0, -2 less than x less than -1, k -1 less than x less than 1, 0, 1 less than x less than 2. So total interval is -2 to 2. Then constant term is, just I am giving hint, later you evaluate. Here L is equal to 2, comparing with minus L to L. Okay, that is the interval is, total interval if you consider -2, 2. So it is also called piecewise continuous. Okay, different function defined in different subintervals. Next, what is your A0 formula? And A0 by 2 is equal to question mark, where A0 is equal to 1 over L, that is 1 by 2 minus L to L f of x dx. This is 1 over 2 minus 2 to minus 1 plus minus 1 to 1 plus 1 to 2. Later you integrate. And one more problem. the coefficient of sin x in the expansion of fx is equal to x square in minus pi comma pi is, okay, answer 0. Hint, you b1 value is equal to, okay, calculate b1, coefficient of sin x, that is putting n is equal to 1, you will be getting b1. What is b1 value? Look at that, okay, this is even function, so bn value 0. Next, Dirichlet's condition. A function fx has a valid Fourier series expansion, that is fx is said to satisfy Dirichlet conditions provided, comma, first condition, fx is single valued, finite and periodic in the given interval of the variable. 2. Fx has finite number of finite discontinuities. In any one period. 3. Fx has at the most finite number of extrema, that is maxima and minima. So these conditions are sufficient but not necessary. These conditions are sufficient but not necessary. So fx single valued finite periodic means already we have defined periodic that fx and its integral values should be finite, okay, and at the most finite number of maxima and minima, okay, in any one period, and it has the finite number of finite discontinuities. I have given the discontinuity definition. So a function fx is continuous at x is equal to a if limit fx extends to a is equal to fa. We have discussed in M1 paper. Whenever these two are unequal, that is called discontinuity. Okay, finite discontinuity means limit value should be finite and not equal to fa, that is called finite discontinuity. Otherwise it is called infinite discontinuity. Okay. So whenever these three conditions satisfy, then compulsory Fourier series exists. That is sufficient. Necessary, not necessary. That means if one of these conditions not satisfied, still some problems having Fourier series exist. Okay. Questions? Over. And while finding a naught, a and bn, you should remember some trigonometric simplification terms, okay, that I am giving here. Sin n pi is equal to 0. Cos n pi minus 1 raised to n if n is equal to 0 plus or minus 1 plus or minus 2. So that is integer. Okay. Cos n pi by 2 0 if n is odd integer, cos 2n pi any number plus 1. Okay. Next, some integrations also you will be getting. Exponential ax cos bx dx is equal to exponential ax by a square. These are already given. A cos bx plus b sin bx. And sometimes you remember integration by parts also. And odd into odd, even into odd, even what I have discussed in calculus, like that. One more example, see. Suppose x square into sin 3x. Again, these things I have discussed already in calculus. Here, which is first function? X square. First function into second function integration. Sin integration minus cos 3x by 3. Next, here onwards, every first bracket derivative into second bracket integration, leaving some gap. X square derivative 2x. Here this is, I left some gap. In that last step, I filled that gaps by alternatively plus minus, like that. Every first bracket derivative into second bracket integration. Minus cos integration plus sine. So this simplifies to 3. While integrating, you should divide the x coefficient. While finding derivative, you should multiply the x coefficient. Next, this bracket derivative 2x derivative 2x. This bracket integration sine integration minus cos. So cos 3x by 27, and for every pair of brackets pre-multiply by alternatively plus minus plus. This tells that integration by parts. Okay. So similarly you find later x into cos 2x dx. Okay. Later you find. So what is the answer for this? X into sine 2x by 2 minus x derivative 1 into sine 2x integration minus cos 2x divided by 2 into 2, 4. Okay. Whenever you get constant, that next term whose derivative becomes 0, that's why I didn't write. So I am giving you two gate question problems in complex numbers. Later you do one. If this is given 2007, 2 marks, z is equal to root 3 by 2 plus I times 1 over 2, then z power 4 is equal to. Okay. Second question. (2008). Just express, I am giving the hint for this problem, express in terms of r comma theta, then apply cos theta plus I sin theta whole power n. Okay. The integral f of z dz evaluated around the unit circle for the function f of z is equal to cos z by z, comma, is. Answer for this 2 pi I. Okay. Answer for this minus 1 over 2 plus I root 3 by 2. That is the answer. This is by Cauchy integral formula, where z is equal to 0 is the only singularity lying inside the unit circle mod z is equal to 1. Then apply Cauchy integral formula. Here first express z is equal to cos theta plus I sin theta form, then apply raised to 4. Next. 3. This is given 2008. The equation sin z is equal to 10 has options: A, no real or complex solution? Option B. Exactly two distinct complex solutions. Option C. A unique solution. Option D. An infinite number of complex solutions. Answer is option D. So I am solving this one. Sin z is equal to 10. Somewhere you write the formula. Sin z is equal to z minus z bar by sin z is equal to exponential iz minus exponential minus iz by 2i, cos z is equal to exponential iz plus exponential minus iz divided by 2. Just remember these two formulas. So this simplifies to e power iz minus 1 over e power iz by 2i is equal to 10. First cross multiply and then simplify and then bring all the terms to one side. So this simplifies to e power iz whole square, but I am not writing e power 2iz. I want to bring a equation in quadratic form. Minus 20i e power iz minus 1 is equal to 0, which is a quadratic equation in exponential iz. So exponential iz is equal to minus b, that is 28, plus or minus b square, that is minus 400, I square value minus 1, minus 4ac becomes plus 4, divided by 2a. So minus 400 plus 4 means minus 396, that means root minus 1 getting I. 396 can be written as 4 into 99, so 2 root 99. After that 2 cancelled, which becomes 10i plus or minus root over 99i. So taking logarithms, iz is equal to logarithm of 10 plus or minus root 99i. So which implies z is equal to 1 over I logarithm of 10 plus or minus root 99i. Yesterday I have given log z is multivalued function. Since log z is multivalued function, that is, it has many answers. Multivalued function means for a single z value. Okay. So therefore z is equal to 1 over I logarithm of 10 plus or minus root 99 times I is also multi-valued. Hence, the equation has here z value is so many answers. So that is z is called the root of the equation. Solving the equation means equation has each is a complex number. Infinite number of complex solution. Solution means we have to find the root of the equation sin z is equal to 10. complex solutions.